paying a lot of money, or kids are going to end up paying a lot of money because they're so like fragile.
Most worried that the district spent too much money total.
Yeah.
So I don't think they made a very good cost-effective decision. We'll see.
Plus, it's the fact that
Okay, so we're going to look at section P3. You are on tape. Okay, so let's look at functions first. Just a review of the basic concept of a function. This is really important. What is a function? Because almost everything we'll be doing in calculus revolves around functions. So things that are not functions are not nearly so useful in engineering, anything that involves calculus. There's just not as many theorems, powerful, really good, strong stuff that you can use on them when they're not a function. So we're really going to be concerned about when things are functions and when they're not. So these two sets, you'll see I've drawn them, they look like Easter eggs, right? Ha ha ha. This and this. What's the set of things that you start out with in a function called? It starts with D.
Domain.
Domain. Where is the set of things that you get to when you operate on the function? Range. So you'll notice that I have picked a particular element, and I'm going to trace what happens to that element and the operations in between that map the element from the place, the location in the domain to the location in the range. That's called the function. Okay? How it does that's different depending on what kind of function it is. We learned about all kinds of functions: exponential, absolute value, parabolas, all kinds of different types of functions that would accomplish that, right? So there's definitely going to be this issue that'll come up several times in class. And I think last year we handled this issue really well. Everyone was real comfortable with it last year. They weren't nearly as experienced as you guys. What's the implicit form of an equation versus the explicit form? Okay. So let me give you an example that shows the difference between implicit and explicit form. We'll have this come up with all kinds of things that we study this year. Okay. So let's say we've got an equation like this. This is an implicit equation. Why?
Because it's equal to 3.
I already said the answer. Haha. Why?
It's
all
there's
about
a
why.
the X and the Y are on the same side.
They're on the same side, right? Oh, I have some good ones. Okay, so the X and the Y are on the same side. You have not solved for Y. Would you be able to enter this in your calculator?
No.
As it stands, you would not. You'd have to get it into its explicit form to be able to enter it in the calculator, or to be able to think about whether it's a function, or to be able to do anything on calculus that depends on it being a function. Does that make sense? Because I don't think this is a function. How do you know? Well, let's solve for y and see what happens. So we get, let's say 2y equals negative x squared plus 5 plus 3, that's plus 8, right? Jeez.
So that's that. But then you just have to take the 2 away?
So
I do.
y equals negative x squared over 2 plus 4.
Okay.
Oh, okay.
We could enter that in our calculator now. It would be what kind of function?
Explicit.
Plus 4 plus 3.
What's that one graph with that?
Thank you. It'd be a parabola that's facing down somewhere, right? Some shifts. It's gone up 4 divided by 2 is going to be some kind of stretch or shrink. So there's the explicit form. Does that look like a function? When you put one thing in, do you get one thing out? We had the vertical line test and some other ways to decide if something was a function. The key, those all depend on the basic definition. When I put one thing in, I better get one thing out. I better not get 2 or 3 or 4 things out. I better only get one thing out. A function is a machine. We went over this before, right? We call it f or g or whatever, and we put things from the domain in it, our x's. We hope, if it's a function, that only one thing pops out for each one thing we plug in. Otherwise, our machine's broken and it's not a function. And we can't do almost anything to it in calculus. Okay? So, when I put one x thing in, how many things do I get out for this equation? Think of an example. Think point-wise. If you put 4 in, you get negative 2 plus 4 is 2. One thing, I'm good. If I put 9 in, what do I get? I'm going to get one thing. If I put whatever in, I think I'm always going to get one thing. This is a function. Yay.
Yes.
Okay.
It's Y-A-Y. That's like skipping Y.
Yeah.
I know, that's
Yeah.
Never seen you stuff like that. I know.
So how about this? If you have y equals 1/2 x minus 3 to the 2/3 power plus 7, something we might see in here for sure.
I don't like
Is that
that.
an implicit or explicit form? Explicit, we've got it solved for y, there's no more y's over there. Is it a function or not? What do you think?
Yes.
I think if I put one thing in and I think about it, I'm only going to get one thing out.
It's a function.
What about this?
No, that's
Explicit
gonna
or
be-
implicit?
Plus or minus.
Explicit.
Implicit.
Implicit. But it's going to be it's not going to
Well, let's solve it, right? We get y to the 4th equals negative 2x plus 7, or 7 minus 2x. So then y equals, Brett,
Plus or minus.
plus or minus what?
the
Square
fourth root.
of.
Oh, yes. I'm so happy with you guys. I'm so happy right now. So that's how many things in for each thing, how many things out for each thing we put in?
Two.
Not
You get
one.
two, the
It's
plus
wrong.
thing and the minus thing. It's not a function. Okay. So that means we will encounter some things that aren't functions in here, but not too many. Okay. Because the power of calculus mainly works with functions. You can use it on other stuff, but not quite as much. General rule. Okay. Let's see if we're still recording, if we're still live.
Just rip it down.
Yay, we're still live. Okay, so let's do some evaluating of functions practice. I'm only going to do one of these for you guys.
There's a fly in here.
Yeah, like an uncooked bug.
Okay, there's my function. That's a very common type of function we might see in this class, something like that. It's got like a hybrid parabola mixed with like a rational function. We'll see lots of stuff like that.
I remember doing this last year.
I hate this.
Let's
Yeah,
say
I
we
know.
want to plug in x minus 1 and then we'll form this guy.
Okay, what is the symbol again? I know you told us, but I forgot the
Change.
name of it.
Delta.
Change.
Delta.
It's
Delta.
the Greek letter delta, which means change. There's all kinds of Greek letters you're used to. You've seen theta for angles.
The God of War, the one that's like this.
Phi, you've seen. There's omega. There's omicron. There's the whole Greek alphabet. Those are all used in mathematics for different purposes. We'll see if
Yes.
those work.
Oh, the fish.
I thought
The
so.
fish.
Fish.
Transformers.
I know it's not fish.
Alpha, beta, yeah. All right, so f of x minus 1, how's that going to go? I'm going to go 1 over, start this off, x minus 1, right? Plug it in there. Where else? Where else,
Minus
Cassie?
x minus x.
I don't understand where you're doing this.
X minus.
Oh, you're putting it up into that. Okay.
Minus. I'm still waiting on Cassidy.
What are you wanting?
It says it all right there.
Let's do plug x minus
Oh.
Minus x minus one?
I swear.
Okay. Okay. So then we get 1 over x minus 1 minus. I hope we don't mess up on distributing minuses anymore, because that'll kill you this year. Watch out. X squared minus 2x plus 1. So I get 1 over x minus 1 minus x squared plus 2x minus 1.
Whoa. Deep breath. Okay. I'm gonna go now.
And then if I needed to, depending on what I want to accomplish, I could combine those. It depends what I want to accomplish. In some cases this year, we'll need to combine those and form a common denominator of x minus 1 in order to find things.
Ugh.
Sometimes we may not.
I forgot.
You're going to want to ask why and what purpose do I need that for, okay? Because it'll save you work.
I forgot. How to put
I'm not gonna do it.
again, but it's okay.
If you wanted to make a common denominator, remember you'd go, okay, that's already got it, so it's done. There's the 1.
Yeah, so then yours.
And I'd say, okay, fix that by multiplying by, and I love this clever 1, right? The clever 1.
Oh.
So you'd
Yeah, I
have,
like that one.
You'd have to distribute, you'd have x cubed stuff, yuck. In that case, it would suck.
Gross.
Okay, how about this? We're going to come upon something like this in our first section, chapter 2.
It's
Don't let this scare you. Follow the notation. This is
You
just
have the
function
change,
notation.
and then you have the original, so you just plug it in.
Exactly. This part's already done for you. It's right there. This part's just the constant. Leave it alone. Don't make this hard. You've got a minus this stuff, so distribute the minus. Why is that plus x squared?
Because it was minus up
I
there.
distributed the minus.
Okay. So what's
Okay.
next?
Alright. I need this still, correct? So you could do that off on the side if you like, or you could stick it directly in there. For many of you, I'd say doing it off to the side is a good way to go. So I'm going to be plugging this into the x spots. So I'm going to go 1 over x plus delta x minus x plus delta x squared. And that's what's going to go in this blank. The real question is, what's my goal, right? If I don't know my goal, maybe I better expand this out a little bit, just like we did with that other one. Somebody help me this time, though. I'm not going to do all the mindless computations.
X
I get tired.
squared plus 2 delta x plus delta
X squared plus
2x
x
delta
delta x.
2x delta x. Why is it 2x delta x, Brett?
Because
Usually, it says, isn't it like 2 and then you have both of your terms, so you
2 times both things is
Yeah.
a shortcut, right? Plus
delta x squared.
then you just
What does it even say? The last one?
delta x squared.
Just delta x squared. Okay, that was kind of hard to read.
So now I'm going to go ahead. I'll try to get out of the way. It's hard. So I've got that minus x squared minus 2x delta x
Oh my god.
minus delta x squared. That's all right here, right? I've still got minus 1 over x, and I've still got plus x squared, and then I've got over delta x.
Okay, well,
Let's see if we can simplify that. No, we haven't really gotten to the good part. This is just review, right? What's this stuff mean? What's that point of doing that? Because there's a point, definitely. But if we look at this, I think we can go like that, right? I don't see anything else right now. Can I cancel anything else immediately?
The following students to Student Services: Caitlin Huddleston, Anna Jordan, Austin Hale,
no.
and Allison Myers to Student
like-
Services, please.
Big chunk of this class, actually.
can we finish this
We're in the
question
size of this
first?
class. Yeah.
Who wants to go tell her? We'll be there in a minute.
Yeah, we'll finish this section and then you can go tell her. Okay, what I don't want you to do is get locked into thinking, oh, I have to do this now and I have to do this now. Be flexible. That's what's going to make the difference between 4s and 5s and stuff like that, 3s and 4s. You could do different things here. Depends on what your goal is, right? Can you just cancel this delta x with any of these
No.
terms?
No.
No, but you could do this. Leave that one alone. Leave that one alone. Those two don't have a delta x in them, correct? Don't you group these two together separately and go minus 2x delta x? If you take out a minus, that now becomes plus delta x squared, and that's over delta x. Look at that. If I split that way, depending on what I want to do, now I can go chop. I can factor that out. And this thing is still a little bit ugly, for sure. But now I have this canceled with each one of those. So now I've got minus 2x minus delta x.
I don't understand what you did to get to that next step.
Okay, I looked at these 4 terms, right? 1, 2, 3, 4.
No, I understand how you split them. I understand that.
Okay.
I don't understand what you divided by. Like, I know you divided by the delta x, but I don't understand how.
So I split 2 and 2.
Oh, okay.
I made that decision by
Yeah,
saying,
those.
oh yeah, those guys both have one of these things, so I could probably get rid of it somehow. And then right here, I factored it out and said delta x taken out of this, I have 2 plus another delta x left.
2x
That's why I
plus.
have that. Notice also, what am I being very careful about? my signs, pluses and minuses. It's tough on that problem to keep track, right?
Couldn't you? Never mind.
Okay. All right, you guys want to go?
So is that the answer?
Yeah.
And
Depends though.
What were they-
Austin asked a good question. Is that the answer?
what were we trying to do there?
I
originally?
don't know. I was just
You
showing you
never
how to be
told us.
flexible.
I'm confused.
Good point.
So
Okay, come on. We'll be.
Oh.
Okay.
Wait, that's it? Okay. No, there's more. They